Okay, chapter 6, rational expressions. This concept is in the section 6.6, and we are going to solve distance equals rate times time story problems. So I have one written down here. The speed of a boat in still water is 32 miles per hour. If the boat travels 72 miles upstream and the same time it takes to travel 120 miles downstream, find the speed of the current. So let's pick this apart and see where all of the important numbers are. We have the speed of the boat in still water. We've got 32 miles per hour. If the boat travels 72 miles, this upstream tells us something, and the same time tells us something that it takes to travel 120 miles downstream. What we're doing is we're finding the speed of the current. So if I'm looking at distance is equal to rate times time, in this case I have 2 trips and my rate has 2 facets or 2 components. So I've got 2 different trips that we're talking about, and the rate has 2 components. Let's see if we can kind of flesh this out. So we've got trip 1. Trip 1 is upstream. So we know that going upstream, you're going against the current. For the distance, we travel 72 miles. If I take this distance is equal to rate times time and divide by rate, then d over r is equal to time. This is important because it said that they're in the same time. So time is the variable that I want to isolate. So I'm going to replace the distance and the rate. Upstream, I'm going the speed the boat is going, plus I'm going against the current. So I've got the boat speed minus the current, and that is going to be equal to the time, which I don't know what the time is. It actually didn't tell me. So for my trip 2, so I'm just replacing everything I do know. For trip 2, it says that it takes, in the same time, so time is equal to, it takes to travel 120 miles downstream. We know when we're traveling downstream, we're traveling the speed of the boat and the current, because it's downstream. Now we want to find the speed of the current. Well, this 72 has been used, this 120 has been used. We know the same time means that these are going to be equal to one another. But there's a couple of pieces of information that we still didn't use yet. We know the speed of the boat in still water, so we know the value of b, or the boat speed, is 32. So we need to put those, substitute those for what we know. The thing we don't know is the current. Again, this one is minus the stream, or the current, because we're going upstream, and this one is plus the current because we're going downstream. Now that I've set this up, and I know that these are equal to each other, because if they're both equal to time, so if this equals t and this equals t, then they have to equal each other. So now that I've set this up, what we're going to do is we are going to cross multiply, and we will get, let's do some quick math here. So when I multiply 72 by 32, I get 2304 plus 72c. That's multiplying this times this. And then I'm going to get 120 times 32. Do that over here. Your calculator would be a lot better. And 120 times 32 is 3840, and we're going to get minus a 120c. Okay, so what we want to do here is isolate c, because c represents the speed of the current, and that's the thing we don't know. That's what we're trying to find. So I'm going to subtract the 2304 from both sides. And I'm going to add the 120c to both sides. Those sum to 0. I get 192c. Those sum to 0, and here we get we're subtracting. Just jokes, guys. Okay, so 0 minus 4. I'm gonna get 6, 3, 5, 1. Divide by 192. And if you put that in your calculator, I believe it is 8. C is equal to 8. So again, C represents this second component of my rate. I've got the speed of the boat and the speed of the current, but C represents the speed of the current in miles per hour. So that answers that question.